Unit 39. Summary of Chapter 2. Electromagnetism, page 105. Write the following sentences in full. To know whether there is a magnetic field at a point A in space or not, we do as follows. Put a needle at point A. If we see there is a force acting on the needle, there is a magnetic field at the point A. How can we transform a steel bar into a permanent magnet? Using a hammer to beat the steel bar strongly, warming up the steel bar on a fire, putting the steel bar inside a tube of a conductor through which electric current flows, putting the steel bar inside the tube of a conductor through which the electric current flows. C is direct current. D is alternating current. The answer is C. Complete the following sentences in full. The rule to find the direction of electromagnetic force acting on an electric current is stated as follows. Place the hand in the magnet so that the magnetic field lines are going through the palm. The direction from the wrist to the fingers indicate the direction of electric current. The thumb indicates the direction of electromagnetic force. What is the condition for an induced current to appear in a closed conductor? Putting a strong magnet near the coil. Putting an electric magnet inside the coil. When the number of magnetic field lines passing through the cross-sectional area S of the coil is great. When the number of magnetic field lines passing through the cross-sectional area S of the coil varies. D. 5. Complete the following sentences. When a coil rotates in a magnetic field of a permanent magnet, an electric current appears in the coil because, well, you tell me. Number 6. Given a straight bar magnet where letters indicate its poles are lost, how can we identify the north pole of that bar magnet? State the rule to find the direction of magnetic field lines. Expression the magnetic field of a DC current carrying coil. Draw a magnetic field line inside the current carrying coil as shown in figure 39.1. State the similarities in the structure between two types of AC generators and the differences in the operation between the two generators. Name two main parts of a DC motor and explain why the motor can rotate when the electric current runs through it. Applications. Put an electromagnet perpendicular to a straight conductor through which a constant electric current flows as shown in figure 39.2. Specify the direction of electromagnetic force acting on point N of the conductor. It goes up out to the page. Transformers. Why do people use transformers to transmit electrical energy away on the same electric transmission line? If using transformers to increase the voltage at two ends of the line by up to 100 times, how many times does the power wasted due to the heat radiation on the line decrease? C. The primary coil of a transformer has 4,400 rounds and the secondary coil has 120 rounds. Apply an alternating voltage of 220 volts to ends of the primary coil. Find the voltage at two ends of the secondary coil. Explain why we can't use a constant electric current to operate transformers. Name two main parts of a DC motor and explain why the motor can rotate when the electric current runs through it. Put an electromagnet perpendicular to a straight conductor through which a constant electric current flows as shown in figure 39.2. Specify the direction. Never mind. Wrong. Figure 39.3 shows a coil placed in a magnetic field. In which case below doesn't an AC appear in the coil? Explain why. The coil rotates round the horizontal PQ axle. The coil rotates round the vertical AC axle.